Alright guys, this is one of the problems that I have had a lot of people ask questions about. It's the wrecking ball problem, and it's asking you from how high above the ground they need to drop it for it to satisfy these conditions of it being 5 meters above the ground and traveling at 11 meters per second at the bottom of its swing. Do note that you guys have a different mass, a different velocity, and probably a different height. So you guys are only looking at this to help you guys do your problem, and then you'll want to use this example to kind of go through it if you're struggling with this one. So the one thing I want you guys to notice first is that the initial height, we can't find that until we know the total energy at the bottom. And so I'm just going to write initial. I don't know this initial energy. I'm going to leave that blank, but what I can do is I can find the final energy. It's above the ground, so it has the potential energy. So I know my GPE, my gravitational potential energy, is mass times gravity times height. Okay, well at the bottom, its mass is 12 because I gave it to you. Gravity, we're using 10, and height, well, it's 5 meters above the ground. Okay? So I can figure out the potential energy there, but that's not the only kind of energy it has. So I'm going to multiply 12 times 10 times 5. I got 600. 600 joules. But it's moving. It said at the bottom it's going to be swinging as fast as it can. If you think about a pendulum swing, at the bottom it's going as fast as it possibly can. And it has a speed of 11 meters per second. And so then I need to look at my kinetic energy. And that's my 1/2 my mass times my velocity squared. And I know those two things. I know that my mass is 12. So I'm going to have 1/2 times 12. And my velocity is 11. So 11 squared. And so that means I can figure out that 1/2 times 12 times 11 squared is 726 joules. So energy, it doesn't matter the type, is always in joules. And that means my final energy, guys, at the very bottom is this plus this. So my final energy is my 600 plus my 726, which is 1,326 joules. Now, energy is great because it can't be created or destroyed. If we don't include any friction or air resistance in its swing, the initial energy has to be the final energy. Now, the initial doesn't have to have kinetic. It could be strictly potential. When they're holding the ball up, it's not moving. So my initial energy is full potential, so GPE. And it's the same as our final, but we had to find this one first. So it's 1326 joules. Now the question also asks you to figure out the height it was dropped from. That's where we are going to use this number. You have full potential energy. So I know that my final GPE is mass times gravity times height. I also know my final GPE is 1326 joules. My mass is 12, gravity is 10, and I'm looking for that height. And so now I just need to solve the math problem. So I have 1326, 12 times 10 is going to be 120, and we're going to divide it. And so when we take our 1326 divided by our 120, we get 11.05. It's a height, so it's in meters. And this would be the height that we'd have to drop it from in order for it to satisfy this condition of being at 11 meters per second at the bottom while still being 5 meters off the ground. All right, happy Tuesday.